I always like to show how buffers balance out the pH, because this is probably the most interesting part to people who look at biological systems and things like that. So I'm going to go back to that very first problem. If you remember the NHF, the salt, where you just throw it in some liquid, some HF that you've got laying around, that little mixture there, if you remember, it came with a Ka value, and then we used the Henderson-Hasselbalch and just plugged these numbers in to the HF equilibrium, and we solved it and we got this pH. So we're going to see how much this pH changes if I do this. Oh, by the way, this is a 1 liter mix because I made this nice and easy. That's what these are all moles now if I do a 1 liter mix. So what happens if I add that much strong base to this reaction? And let's just say that the strong base is like NaOH or something like that. So here's my reaction. I've got my HF, because it's not going to be interested in the Na, it's not going to be interested in the F side of things. It's not going to be interested in that because it's going to be looking for something that has a hydrogen. So HF is the side that's going to be affected with my NaOH, and it's going to make NaF plus H2O. Now initially, we already know how much HF we have because our little buffer is established, and we initially already have some F, because that's the whole thing of a buffer. You've already got some of both sides of the reaction. And then now what I've added in is 25 moles, 0.25 moles of NaOH. Now, it works the same way as anything else. You're just looking for the smallest number, and you're just subtracting it out. So I'm going to subtract out, oops. I don't know how I end up with a line there. 0.25, 0.25, and I'm adding 0.25. And the water part doesn't matter. And when I do this, I'm going to be left with 5.7. No, 1.07. No, it's 0.57. Sorry. I'm not having a moment there. And then over here, I won't have any of that. So the buffer is cool. And then I've just generated 0.76 of this NaF. So let's go back to our Henderson-Hasselbalch, our pH, and our pKa. I'm going to go ahead and just fill it right in. It's the log of 6.4 times 10 to the minus fourth. I don't know why I'm suddenly getting lines. Plus the log of, and again, it's the salt, which is now 0.76, over acid, which is, wow, my screen is going crazy, 0.57. So let's see how my pH deals with that. So if it's a good buffer system, that pH is not going to have a huge shift. So I've got negative log of 6.4 e to the negative fourth plus the log of 0.76 divided by 0.57. That gives me that the pH is 3.319. Make sure I put all those numbers in well and make sure it all makes sense. Yeah, so my pH has gone up like a factor of like, what, 0.3, something like that? That's not a huge change because I was already at a pH of 3 to begin with. Let me get those numbers back. So let's see what happens if we go the other way. Let's say instead of the strong base, we're going to add 250 milliliters of a strong acid. To the reaction. So we're going to now, this time the HCl is going to be interested in the F portion. So we have HCl plus, if you wanted to do NaF, that's cool. And that would give you HF plus NaCl. Because it was originally the NaF is what it was. But if you want to write it as F minus, it's okay also. Sometimes people have an issue with the Cl floating around if you don't include it. So then initially, remember on this problem, initially we had that much F minus, so 0.51, and then we had this much HF, 0.82, and then our HCl is what we've just added in, this 0.25. So again, we look for the smallest number, subtract it out, minus 0.25 plus 0.25. And so that's 0. This number here looks like it's 0.63626. 0.26. And then over here, this is 1.07. That one's 0. That one doesn't matter because it makes a neutral salt. So let's do Henderson-Hasselbalch again. pH is equal to the negative log of 6.4 times 10 to the minus 4th plus the log of, and our salt happens to be other side, so don't lose the salt. That's NaF is the salt. 0.26 over 1.07. So negative log of 6.4 e to the negative 4th plus the log of 0.26 divided by 1.07. And so now we can see that our pH value here is 2.579. And again, from the original, which was 3, it's only gone down like half of a pH. Notice that we're adding some super strong acid, strong base. We're adding a huge amount of it, and yet it doesn't change the pH by that much. That's a pretty cool kind of a thing right there.